Okay, students. So once again, I'm speaking over here. Today we have a topic, a relation model, in which we have a relation algebra. And relation algebra, we will see the select, project, rename, union, intersection, set difference, Cartesian product operations. But why these operations are required, and what is a relation algebra? These are the two biggest questions we must have. So before moving to the various operations, let us discuss what is meant by the relation algebra under the relation model. Let me inform you once again, the relation models means we are talking about the model which is depicted or which is identified by the 2D manner, that is the rows and column. And identifying the such scenario, we have a relation model. The information will be represented by the in form of the tabular form. So inspired from this story, we have a relation algebra. But why relation algebra is required? To give you some idea, I have the simple terms over here. In this slide, what I have the relation algebra is a procedural query language. This is the biggest point. Relation algebra is a procedural query language. What does it mean? It is taking toward, it consists of a set of the operations that take one or two relations as input and produce a new relation as their result. So in the previous class, we have seen that we have the two types of the query language. One is a non-procedural, other one is a procedural query language. In that point, we have to understand the thing process properly. In the procedural query language, we know what is the thing we are getting, but how we are getting. What we are getting, that is important, but how we are getting, that is more important. So in the relational algebra, we will know how to get the thing. But in case of the non-procedural language, non-procedural query language, just like the select, from, where clauses. So with the help of those clauses, we have to understand what is the data we are getting. We know, but how the data we are getting, we don't know. So inspired from that part, we have a relation algebra. So relation algebra basically completely followed by the mathematics operations. We have a small sentences by which we will see. So relation algebra is a procedural query language, means in this relation algebra concept, we will know how the information we can get and how to retrieve the data, how to get the data. But in the case of the non-procedural language, we don't know how to get the data, but we know what data we are getting. It consists of a set of the operations that take one or two relations or relationships. We're talking about the tables. So in the relation algebra, we will speak the table, we will speak about the relations rather than the table. We will speak the tuples rather than the rows. We will speak the domain rather than the columns or fields. So these are the important ones we have to understand, but only naming convention we have. So the fundamental operations in the relation algebra are the select, project, union, set difference, Cartesian product, and rename. We have a 6 basic operations. In addition to understand this fundamental operations, we have the several other operations. These are the 6 fundamental operations. But other than these operations, we have a set, intersection, natural join, division, and assignment. So the point we must have in our mind as a mathematically, I can speak over here. The operations can be done by the various way, but we have the suppose unary operation, or we have the binary operation. So when we have the two operands, then binary operation are required. When we have the one operand, so we have the unary operation. So depend on the requirement, we will understand all the things. So fundamental operations will be mostly focused on the unary operation. So that part we will see over here. So select, project. Okay, all these are the important terms where we have the unary operation. From this point, we will understand all the things step by step. But there is an important terms I am remembering over here. Student ask me the question, sir, what is actually relation algebra? So for removing the curiosity, I have the simple example by which I can explain. So that's why I have this blank slide in which we have the entire thing properly. So let me explain all the things properly. Why relation algebra? This is the big question. Why relation algebra? That is a point we have to understand. So I'm just writing the thing properly, so the picture, the idea will be clear to. Yes, this one. So I have the question: why relation algebra? Why relation algebra? Why relation algebra? That is a big question I have. So in the relation algebra, just before, let me inform you all once again, and let me give some idea. We have the two type of the language. One is a non-procedural. I can speak over here. One is non-procedural query language. Next we have procedural query language. Next we have the procedural query language. These are the two query languages we have, or these are the two flavors. In this case, we know what we are getting. What we are getting, that is a point you can understand. But we don't know how to get data. We don't know how to get data. This is the second question, is not fulfill this requirement. But in the case of the procedural query language, we know what we are getting, but we won't know also how to get the data, how to get data. So procedural query language, we have the two parts we will see. That is, one we have the relational algebra. Next we have the relational algebra, or relational algebra we can say. While in the case of this part, we have a PL/SQL. This part we will see in detailed manner, that is a practical part. So practically we will see all this. Now come to the point, that is more interesting point. When talking about the relational algebra, so now let us move to this point. Why relational algebra? See, if I'm writing any query, just like I'm writing the select all the fields from a table that is XYZ. So from this point you can observe over here, I'm selecting all the attributes. I'm just marking in a box. You can see I'm selecting all the attributes. So what I'm doing, I'm performing the first, I'm using the first clause, that is the select. So how many letters are required? Very practically speaking, I can speak over here. I need the 6 characters to store this statement as a select. 6 characters are required. So what I'm doing, instead of these characters, can I use a one single character? It is also possible. So in the relational algebra, we will use, or we can say we use mathematical symbols to perform operations for queries. That is the point. So if I'm writing over here mathematical symbols. So this is used to simplify your problem. So if I'm using a single operator, suppose I'm using a single operation, suppose I'm using a sigma. For sake of the knowledge, you can understand. Suppose I'm using sigma. This is sigma. Suppose I'm using. So this symbol is required only the one character. This symbol is required only the one character to occupy in the memory. So that is the point we have to understand. So 1 byte memory is required. So I can speak over here. Practically I can speak over 1 byte memory is required only here to store such symbol. But I'm talking about six character. So 6 bytes are required. So you can easily say, when we deal with the relational algebra, we save the memory, we save the time. So executions of our query will be faster inside the relational algebra. So in the database compiler, what is the role of the database compiler? That is we can say database compiler. So database compiler, just compile the queries internally by relational algebra. Okay. Relational algebra. Now this is clear to all right now. Is it clear? This is a summary which describes the why relational algebra we have to use. So relational algebra is used to understand how to get the data. Yes, tell me.
So in procedural query language, we know both the things, like what we are getting and how to get it.
Yes, definitely. This actually, as a user perspective, we have only the what we are getting, but as a computation purpose internally. So this is actually, uh, just let me use a different color so the idea will be more clear. What is actually doing? The compiler or our query processor actually. In talking about the query processor is used to process the query. So query processor at the level of the query processor, we know how to get data. If there is a communication between the user and system, so if there is a communication between the user and system, then user will know how to get data. User will know how to get data. That is the point. But in the case of the non-procedural query language, we don't know how to get data. So while writing the query, just select star from the XYZ. Are you know how to? Are you able to know how to get the data? Does any processor is required? We are not following any procedure. We just using the simple clause by which we are just defining these are our attributes of fields, and from such table we need to fetch the data only. So we are expertly defined, so everything will be done over here as explicitly. Everything will be done over here as explicitly. But in the case of the this relational algebra, when you're dealing with the mathematical symbol, it directly deals with the database compiler, so it will save some time to retrieve the data. So that is the reason relational algebra is most applicable. So in the many books, you will read only this statement. This is a procedural language, and it consists of set of the operations. But why relational algebra? So that's why I'm explaining over here all these concepts with help of the simple way. So now it is clear to all right now.
Yes, sir.
That is only meaning, because whatever you are see as a user, I'm taking simple example from the beta, you are accessing the data. Do you have any right to how you are accessing? You don't know which database you are using. You don't know which tables you are using. We don't know. So you just getting the data only. I just need to see the my result only. I need to see the data only. But you don't know how these data are retrieving from your database to your screen. You don't know. But if I'm using the process query language, so I need to explicitly define everything. How to get data means I'm explicitly define everything into the my core, into my query, how we are getting all these things. So as a practically at the time of the PLSQL, when I will discuss the PLSQL, so you will able to understand how to get the data, but the practically I will tell you, okay, I will explain all the things. That was the point. So relational algebra is a procedure query language because it will support the mathematical or notation symbol from which we will define everything. So when we have the definitive part, we have the explicitly we are defining everything. So it means we are following the procedure, as the name suggests, procedural. So we have some procedure by which we are following the our query language part. In the non-procedure query language, we just know what we are getting, but we don't know how to get the data. That is only meaning. So as a user from the internet, you are seeing so many things, but are you really know all the things? You are getting all the things with the such table? No, that is only point. So this is a little bit difference we have to understand. All these things are not written into the books, but this is only coming from the experience. So I'm sharing all the my points over here. Yes, right now. Is it clear to all right now?
Yes, sir.
Yeah. Okay. Same thing I have explained over here with the other notes. So this is a point I have over here. So no issue. Same thing we have. So database compiler will use internally the symbol to manipulate your query. So definitely. So relational algebra based information will be manipulated in a simple way inside the computer machine. So same thing we have used. Same symbol I'm using here. Okay. So this is the same thing. So let us move to the next part. That is describe the what is the flavor of the relation operation. So what is the relation type? You can say. So two types of the relation operations we have. One is a fundamental operation. So in the fundamental operations, we have a renew operation, select operation, and project operation. But in the case of the additional operation, those are recognized by the union, set, intersection, set, difference, and Cartesian property. So step by step, we will discuss. Now, fundamental operations. Fundamental operations, we have the select, project, rename, and operations are called the unary operation. Why unary operation? Because when performing any operation on the such by using such operation, only one table or one relation is applicable. So that's why we have this operation name. Those are the select, project, and rename. These are the three different operations which are undercoming to the unary operation. Now, other than three operations operate on the pair of the relation, and those are called the binary operations. So what are those operations? Unary, set, difference, set, Cartesian product, intersection, of course, So relational algebra, I have already written over here. For your betterment, I can write one more over here. To use fundamental operation, one relation is applicable, as we have seen. In the structured query language, or in the writing the MySQL while writing the practical time, we can use a term that is the table. So, but in the relational algebra, in the this term, this is the term, yeah, relational algebra, and this is intercoming to this one. So, relational algebra, we have a relation, and but in the SQL we have the table. In the relational algebra we have tuples, but in the SQL we have the records. In the relational algebra, we have to use the term domain, but in the our SQL or just while seeing the practical part, we will use the term attribute, fields, columns. So these are the same. So these rows we can in general term or in general term what we have to use database. We have a rows, or we can say this is our attributes. So these all are terms in terms of the general view. You can write it over here in general. In general. So these three terms are, so all these are nothing, these are the naming convention. So while discussing everything in this concept, you will not allow to forget any term. So that's why I'm just giving the idea over here. And now it is just only the naming convention, the same sense we have over here. Table relation or database we can say over here. Record, tuples and rows we can also have the same sense. Column, domains and attributes we are also having the same sense. But domains is a little bit different. That is the point, because domain will work on the set of, actually domain is saying to us, I can speak over here. Tuples means we are talking about the set of the rows. Set of the row data, actually set of the row data, you can write like this one. And this is representing the set of column data. Okay, column data, that is only meaning. Now this is clear to right now. This basic difference should be clear. Domains means set of the column data, and tuples means set of the row data. Now it is clear to right now. Yes, tell me, is it clear to? Yeah, okay. So keep in mind when we have to discuss anything. Now, let us discuss the first point. Everything is written over here, select. So the select operation select the tuples that satisfy the given predict. So predict means we have to put the condition. So I can write over here, predict means we're talking about the condition. Predict means I'm talking about at this point, it means I'm talking about the condition. So the select operation selects tuples that satisfy the given condition, and we use a lowercase Greek letter, that is sigma, we have to use to denote the selection. So it means when we perform any select operation, then we have to use this symbol properly. And the predict appears as a subscript to sigma, and the argument relation is in the parenthesis after the sigma symbol. So syntax of the select operator, we have to use the sigma symbol, and this is the syntax we have to keep in mind. Sigma condition or predict we have to use, and then in after that part, after using the parenthesis, we have to write the relation name or table name. So it return the number of rows. So the point we have to understand, it is already written over here. What it will return? It will return the number of rows. Okay, so I can again put into the box or put into a circle. What does it will do? It will return the number of the tuples. That is a point you have to keep in mind. It means it will return the number of the rows. Now, this syntax is clear right now. It's very simple problem, and now it is clear to all right now.
Yes, sir.
Okay. Yes, tell me.
I didn't get the number of tuples one.
Number of tuples means number of the rows, or in the rows we are not getting the single tuple. We can get the many number of rows. So see, this number of tuples means we are talking about the when we are using the join operation. So while using join operation, we will use the multiple tuples or multiple columns or multiple tables. So when we have the multiple columns, we are dealing with the multiple tables, columns, and attributes and other things, then number of the tuples will be common or number of the tuples will be duplicate. So here it means number of tuples means I can write over here for betterment. Number of tuples means a set of rows composed by many tables. And this number of the tuples terms will be applicable while discussing with the join operation. But before moving to join, let us just understand the basic terms right now. So it returns the number of tuples. It means it will return the number of the rows. How many rows we have? It returns the number of the set of the rows. So it will return the number of the set of the rows. And rows could be the one set of the one rows. Single rows could be possible, and multiple rows also possible. So that's why it is written over here a set of the rows and composed by the many tables. So it is also possible to apply this selection operation on the multiple tables. It is also possible. That part we will see in the join operation. But this fundamental syntax should be clear. So now it is clear.
So the sigma returns number of rows.
Yeah, of course. Sigma is a mathematical symbol which returns the number of the tuples or number of the rows. Of course.
Okay, sir.
It is just simple syntax. See, if while I'm using the very simple syntax, select. See, this is. I'm writing a very syntax one. Just this syntax I'm writing. Select. Just look at this example. I'm writing select employee name. Suppose I'm writing select employee name from employee table. So what it will do? Can you tell me right now what it will do?
So it will it will display the all the data in the ename from employee table.
Yeah, that is a good point. It means it will return the number of the rows and number of the values that belong to the employee name from the employee table or employee relation. So it will display means it will return. That is the point. Same thing
Yes.
we are happening with the selection operation. Now it is clear. I can write over.
Yes.
I can write over. Yeah, it returns the total. I can write over here total number of EMP from EMP table. Now clear? Now this is clear right now?
Yes, sir.
Okay. Yes, this is the point. Now, are you able to see this diagram?
Yes, sir.
Okay, good. So this is the point. Again, I'm explaining over here. So I have already given the so many things over here, but for your betterment, I can speak over here. How many columns we have? 3 columns: customer ID, customer name, customer city. So total number of the column we have. So that is also known as the degree of the our table. So I can write over here for simplification. Degree of this table we have the 3. That is number of the columns. Now clear? Step by step I will ask. Now it is clear?
Yes, sir.
Yes, sir.
And customer name or relation name, we have the customer. Okay, so this is a table name. You can say this is a table name. You can say this is also table name. Only just naming convention we have. Customer ID, customer name, customer city these are the column name, but in this is known as our domain name. But domain name we have. This is the only table name, attribute name, or field name. But what is a domain? Domain is saying to us this is what customer name. So this is the our set of the data value which is associated with the data, column. So what is the domain name? Domain name we have the customer name. So this is known as the domain name. But in the question paper or somewhere you are reading the domain. So what is domain? Domain means a set of the data which are associated with the column name. So this is not, this is the domain. That is set of the columns values. So its column values, that is customer name column value, we have the Steve, Raghu, Chetan, Ajit and Kar. So these are what? This is the domain. Now clear? This term is clear?
Yes, sir.
Yes, sir.
Okay. So here this is the how many tuples we have? 1, 2, 3, 4, 5. So in the customer city, how many tuples we have? 1, 2, 3, 4, 5. That is the only thing. So tuples means this is the first row, second row, third row, fourth row, fourth and fifth one. So how many tuples we have? We have the 5 tuples. So it is also written over here. That is the 5 tuples. These are the basic terms we have to understand, and then you can easily understand the numerical portion of this. Today we will see the numerical portion. So before moving to the next slide, the table which contains some data and what is the name of, or what is the naming of all these terms. Now it is clear what is domain name and domain and tuples, and what is the relation name and what is the degree.
Yes, sir. Clear.
Okay, and what is the
Yes.
total number? Yeah, total tuple we have 5.
5.
No. Degree of the table we have the 3, tuple we have the 3, or the tuples degree of the table we have the 3, and tuple we have 5. Okay. Okay, right now. And these two terms
Yes,
are, yeah, okay. Now next, let us move to the this point. Just select customer details from the customer relation where customer city is Agra. This is a caution. In an English statement, it is written into our slide. Select customer details from customer relation where customer city is in Agra. Okay, so if I writing this query into the SQL form, then how I can write? Select star all details. So it means star means all attributes from the customer relation, and select all the fields, all the attributes from the customer relation, and where condition customer city is equal to Agra. Now this SQL is clear right now.
Yes, sir.
And this SQL I'm just transforming into the relational algebra first. So how I can write? I can write in simple way, that is the I can write over here for understanding purpose. Select customer city, okay, and that should be the Agra. From which table or relation? Customer. So this is a syntax to write the same queries into the form of the relation algebra. This is a transformation form of the our query which is written along with here. And if you do not want to select all the fields, if you want to write this one as a only customer city, then it is also applicable. If you want to write this one, then you can also write this one. Select customer city, we are putting the condition. So what is the syntax? If you remember the previous one, just move to the syntax. Sigma condition, then relation and table name. So what we have done here, we have given the condition here. Sigma I'm using, and I have given the condition, and this is the table. So this is the what? This is the table or relation name. So I'm following the proper syntax, and this is what, this is our condition or predict condition, or we can say this is a predictive. Okay, now clear right now? This query is clear?
Yes, sir.
Okay, so what is the output from the table? What is the output? What is the output? Just tell me. Just see, this is a table. So what would the output? With the customer city, we have the Agra. So that is Agra. So these customer city, if I'm choosing, then Agra will display 2 times. But I'm selecting all the attributes, so then it will also display the customer ID, and it will also display the customer name. Okay, so this would be our output. So this is our output. Now it is display, and it is, visible to all right now.
Yes, sir.
So this is the select. But selecting, we are choosing here select operation, just selecting data, but it will not display data. But here I'm just giving the output over here for your understanding purpose. So what we have the select first operation, that is the fundamental operation we are choosing. Next operation we have the project. So project operation is similar to the select, but it is used to display. From the relation we are fetching the data and we are displaying something over here, so that is what we are using the project. And select is just used to select the data only, but it is not used to display data. So what you have to use for understanding purpose, I'm just displaying over here, but at the exam time you have to keep in mind all the things properly. So select is used to select the data only, but in the case of the project we have to project data. Project means display. And next function we have, or next operation we have this one. But the other slot I have already explained. So in general, we allow comparison using this one. So this is all. These are the relational operator. So in the primary programming language, you have seen this point while studying the programming language. So you have already seen these are the relational operator. These are the relational operator, or this is also known as a comparison operator, or this is also known as a comparison operator. So these operators are used to make the comparison of your data, or you can put the condition purpose. If you want to display the greater than, larger, smaller than the is, or you want to specify the condition that should match with over here. So all with respect to all that part, we have the relational operator. So see, in the previous part, we have seen this one. In this line, in this syntax, we have used the customer city is equal to Agra. If you want to put the prediction of condition, customer A should be 30, more than 30. So we can use the greater than or smaller than, whatever you want to use. That is a point we have to keep in mind. Now, so furthermore, we can combine the several predicted. Predict means I'm speaking the condition into the larger predicted by using the connectives, and those connectives are the and, or, and not. Okay. So this is applicable when we have to apply the multiple condition. Okay. So these connectives are applicable. I can write over here. These connectives are more applicable when we are dealing with multiple condition, Okay, suppose I have to choose a customer name, those who belong to the customer city Agra, and the customer name is Steve. So I can easily see that there will be only the one record. So at the time we have to identify what is the condition. So and I'm using, so for the and, what I have to use, I have to use the connective that you can see over the screen. Now clear, this point is clear. So this is the important point. So now clear right now. For anyone who need to ask any question. Yes, tell me, any doubts so far? Yes, tell me, any doubts so far? No. Good. Next, we are moving to the next part. So project operation. Project operation allow to produce this result only, but this used to display data only. So whatever you are selecting, that we have to use the select operation. But after selecting, what we want to print, display. So the project operation is basically, definitely we can say it is a unary operation, and that returns its argument relation with the certain attributes left out. Since the relation is a set, any duplicate rows are eliminated, and projection is generated by the uppercase Greek letter. Small lowercase Greek letter we have the sigma, but uppercase Greek letter we have the pi. So we list those attributes that wish to appear in the result set, or result we can say, as a subscript of to pi, and the argument relation follows as a parenthesis. So pi, column 1, column 2, what is the column, your number of the column you want to display, then you can use this thing. So that is the only point we can say. Let us take this example right now. So I have already taken this example over here. So I want to select the customer details who belong to the Delhi city. So and display his or her customer ID. So what I have to do? I'm selecting the customer city belong to the Delhi. So that is the part I'm choosing over here from the customer relation. So what I'm doing, I'm performing a selection operation. Here in this point, what I'm performing, you can easily check. First, I'm performing the selection. And then I'm performing here projection. Okay, so definitely we have to use this point right now. So what it will display? It will display the two. Yeah, it will display the two records Delhi. So these are the Delhi customer city is equal to Delhi. So these parts are selected. So this row will be selected. First, what happened? This row will be selected. Okay, and now I want to display all this customer details, all the customer details or customer ID only. Suppose I want to display the customer ID, so only C10117 and C10118 will be displayed. So what I am choosing over here, I want to display only the customer ID. So what it will display? It will display only these two customers ID. Because what I'm printing, what I'm displaying only the customer name. Now clear? This query is clear?
Yes, sir.
Yes.
So this is our this is the point. Okay, and now I am just displaying here customer city and customer name. No condition I am putting. It's of customer condition we can put there. Customer condition will be applicable in the selection part. So here I'm just only displaying. So I'm just need to display all. I'm just displaying the customer city and customer name from the customer relation. So from the customer name, customer relation, customer city and customer name will be displayed. So all the data, customer name, customer city will be displayed. Customer name, customer city, Steve Agra, Raghu Agra, and Chaitanya Noida, and Ajit Delhi, and Karl Delhi. So these are the 5 tuples we have. So all tuples are displayed over here. So this is the basic differences we have to know. Select condition we can apply in the selection part. So select, you have to use the lowercase sigma. So we have that one. Uppercase pi you have to use for the display purpose only. So condition in the display part, you are not allowed to put the condition. You can just use the display. So if you put in the condition, then use the appropriate symbol. Suppose I am using the condition by using calling by the pi symbol. My query will be wrong. So definitely we have to keep in mind this one. Now clear right now? Is it clear to all right now?
Yes, sir.
Yes, sir.
And I'm explaining once again over here to my those students who are just weak to understand some steps. So suppose you are putting this condition pi customer name is equal to Raghu, suppose that, and from the customer. So what happened? It will give us an error. That is not possible. Why? Because of this one. This is used to display purpose only. So rather than you can update the query, two options. You have a two option. Either what we have. A, you can change the symbol. You can write like this one. It's called to Raghu. All the things should be in subscript form. So please keep in mind. Okay. This is another way by which you can do. So what we are doing, you're selecting all the record whose name are the customer Raghu, or B is saying to us, you can do not want to if you do not want to change the symbol, then keep it as it is. Customer name and remove the condition, so that this option will be. These two queries are the correct. Now clear right now? Now is it clear to all right now? So just for display purpose we can do. We are just displaying. We are not selecting. We are just displaying. Now clear right now? Is it clear to all?
Yes, sir.
So sir, by select we can also display.
Yes, of course, we can also display. That is the beauty of the selection operation we have. So from the select operation, we can also display.
Then, sir, what is the benefit of using display over select?
See, but naturally we can say if I'm selecting the anything from the data, but it will not display. But for understanding purpose, we are displaying over here. But very practically, if we're talking about over here, it will not use to it. The aim or the purpose of the select operation is not to display anything, just to select the data. It is just like simple example. If you are playing a game and I'm just giving you a message, okay, select the 5 balls in a basket. So what you are doing, you are selecting. I didn't ask you, I didn't inform you. You have to show me the 5 selected balls. Why? Because so by default, what you will do without giving my message, you will show, sir, I have chosen these 5 balls. But I didn't ask you. I didn't ask you. I didn't inform you. You must show me all these selected 5 balls. No. But by default, what happened? You without giving any message, you will show me, sir, I have selected the 5 balls. So this is just happening with like this case when we are displaying, we are selecting any data. So undoubtedly we can say implicitly we have this option, we can display. That is only meaning. Now, it is clear right now?
Okay. Yes, sir.
Okay, so yeah, that is a point we have to understand. So if I'm not using by default, I'm not using display externally or extra, or we can say the extraneously, I'm not using, then what happened? Undoubtedly, I have to use or I have to display the content. That is only meaning. So all these points you have to keep in mind in the exam time. So what I'm asking and what you have to follow. So to avoid the mistakes, I have taken with this example. So now let us move to the third operation. So fundamental operation, we have the three operations: select, project, and rename. So now it is time to see the third operation, that is rename operation. Rename operation is just like as a aliasing. Okay, that part I have not explained over here, but you have remembered the one query where I have changed the my column name while discussing the aggregate function. So what happened? I am just giving the total. I'm giving the count function. If you remember the count function, just let me explain over here. If you remember this query, I think so. You have remembered or not? Select count, and I'm passing employee name. Suppose that I'm passing this point as total employee from employee relation table. So it will not display in the MySQL. It will not display the count EMP name. It will display the total name. So this is what I'm just renaming. Just for display purpose only, I'm renaming. I'm not changing actual attribute name as a total EMP. It will use only for display purpose only. So that's why we have the here option to rename. So I'm renaming only. This is known as aliasing. This is known as aliasing. So I can write over here. This is known as aliasing. Now clear, this point is clear, this query is clear right now. Then I can explain the rename operation.
Yes, sir.
And for using this point, we have a row. Okay, so we have to use a lowercase Greek letter row for displaying the such part. So rename is what? Rename is just unlike the relation in the database management system, or we have any database. The results of the relational algebra expression do not have a same name that we can use or refer to them. So count employee name should not be displayed. I want to display the total name only. So we can use or refer to them, and it is useful to able to give them names. And the rename operator, that is denoted by the Greek letter row, we have to use. Let us understand this point. This is a customer relation. So what is the customer name? You can see customer name. If I want to change, that is change. Row customer name and display customer name and color. So what it will display or what it will do? What it will do? Yes, can anyone tell me right now? What this query will do?
Sir, like this will alias the customer name, like customer name to cust names, and will display all the customer name from the table customer.
See what happened. We have a two queries. So I have written over here. So I'm just explaining this part. Internally, this query, this is a query. So this is a query one we have, and this is our this. So we have two queries. Am I right? This is two queries we have. Query within the query. Yes, tell me. This is known as a query within the query.
Yes, sir.
So first query will be executed. Internal query will be executed first. So what is the first query? Display customer name customer. From the customer relation, it will display all this. So in the memory, what will store? What will we keep? Customer name, that is actual attribute name, that is customer name. So it will have the Steve. It will have the name Raghu. It will have the name. What's the name of the customer? Chetan. Okay. It will keep the name, and next it will keep the name Ajit, and it will keep the card. So in the memory, what will it will keep the information customer name and all the name of the customer. Now this part is clearly written. This query will return this point. This is the output of, we can say, this is the output of internal query. Right now it is clear.
Yes, sir.
Okay, good. So after this point, now I just want to rename the customer name. So I want to rename the customer name customer name as given in our query. So what it will display? It will display the customer name, or it will rename actually. First it will rename and then display. So what it will display? It will display the name as it is. So we are not changing any data. We are just playing with the column name only. So Steve, Raghu, Chaitanya, and Ajit, and Carl. So that will be displayed as it is. Let me show the micro customer name. Steve, Raghu, Chaitanya, Ajit, and Carl. Now this is the what this is known as the our row operation. Now it is clear to all right now.
Yes, sir, got it.
Okay. This is the other slot I've explained. So that is the point we have taken. Rename, I've explained with the other slot. So I have all the content over here. Yeah. So now let us look at the other part. So I have this exercise to all the people. So let us discuss this exercise over here step by step. So consider the following relational database schema consisting of the four relations schema. One is passenger, agency, flight, and book. So passenger, we have a PID. Okay. P name and passenger gender and passenger city. So PID from the passenger relation, we have a primary key. So it is already marked by me over here. So you can see that is a PK. So this would be your primary key. Next agency relation, we have a AID, that would be the primary key. Okay. And agency name, agency city, we have this one. Okay, because agency name, agency city could be many, so duplicacy will be here. So agency ID cannot have. Same passenger ID. Flight ID would be the primary key, of course, undoubtedly. Flight date, flight time, and source and destination. We have to keep in mind all this one. And booking, we have PID. So PID is what? This PID cannot be the foreign key. So this cannot be primary key. This can be a foreign key. Why? Because at the time of the booking, we will keep the detail of the passenger, we will keep the detail of agency, we will keep the detail of the flight. So its primary key or key attribute will be considered as over here foreign key. So that's why all this one. This is the point we have to understand. Now it is clear to all right now. This is clear. This table is clear. How many?
Yes. Yes.
How many relations we have and what are the primary key, what are the foreign key. So I suggest to all the people right now and just tell me what would be the output. So in front of you, I'm expecting everyone will give the reply. So what would be the output? So let us discuss this one. Yes. Get the complete detail of all the flats initially. Just tell me the answer. What would be the answer? Just write the SQL. Just write the its relational algebra query. I'm speaking once again at the time of the examination. Do not write the SQL if I'm asking the relational algebra query. Okay, so do not mix up the thing. Just please tell me right now.
Uh,
Just get the all the details, complete details of the all the flight to New Delhi. Tell me what would the output?
Sigma
So
flight
sigma,
destination is equal to New Delhi.
So I can write over here for a betterment. You are telling me get the complete detail of the all the flight to New Delhi. So condition is given. So sigma we have to. So I need to select the flight of the New Delhi. So what would be flight of the New Delhi? So I have to choose a which uh, attribute flight. Okay. So SRC source flight to New Delhi. So I didn't like I will not choose the source. I have to choose the destination.
So destination.
Destination. Okay, that's a great one. So I'm writing once again over here correct skill. Yeah. So destination equal to New Delhi from the flight. Now clear right now? This query is clear?
Yes, sir.
Yes, sir.
Okay. And same queries we have over here. Get the details about all the flights from Chennai to New Delhi. The from
yes,
means
sir.
which is source. So I can write over here. Yeah. So I can write over here.
SRC
Select.
Chennai.
Yes, good. Chennai and flight. In the exam time, do not write the select flight ID or select, and so do not write unnecessary. Just write the appropriate terms. So while writing anything on the exam in the exam time, please do the take care of the query part or SQL relational properly. So read the question paper correctly. So I'm sharing the answer over here. This answer self destination is equal to New Delhi. Friends, we have the same answer. Yes.
Sir.
Yes, tell me.
So for that, yes, sir, that will be the answer. We'll use and right.
Because what we have the two cities over here, so we have from two, so that's why we have to use a and.
Yes, sir.
So we have to use a and of and then destination equal to New Delhi. So while writing the queries, it is an art. If you are missing all these things, you will lose your marks. So this is the point you have to keep in mind. Why? Because it is given to the Chennai. So you have written the sources of Chennai, but we have solved the half part of the query. So next part is saying to us we have to move from Chennai to New Delhi. So what happened? Destination should be New Delhi. So that's why I put it over here. Now clear? Is it clear to right now? This query is clear?
Yes, sir.
Good. This point should be clear to all right now. Okay. The select operation, we have used this symbol. So this symbol is known as a sigma. We have used a symbol for the project operation. We have used this symbol, that is a pi. This symbol is we have used for the row. So we have used the symbol name is row. Okay, this is not p. This is treated as just like this. Okay, so this is known. So what are the other operations? So these are the basic operations we have seen, but now it's time to see the some additional operator, additional operators. Let us move to some additional operator. First one is union operator. So why these are the additional operation? Because these are undercome into the, I can write over here, these are undercome into binary operation. Okay, so that's why we have the additional operation. So union operator is denoted by the U symbol, and it is used to select all the rows tuples from the two tables. So we have the binary relation. So syntax would be the first its relation name or table name. So I can write like this one. Just we can say relation 1 and next one is relation 2. So we can write in shortened way. Now the syntax is clear.
Yes, sir.
Okay, good. So we have two tables. Now it is clear to all right now. Two table is visible. So what are the tables name?
Course and student.
Yeah, good. So just apply the union operation. So what we can get? Just apply the addition union operation between the course and student. So what you can get? Can you tell me right now? Just tell me. What would be the output? Tell me right now. What would be the output? Just tell me right now. What is the output? The customer ID we have. This one is customer ID. Student name we have. And student ID we have. And this is a customer ID. Student name. And student age. So So what would be the output of this one? Yes, this is the query I am writing over. Display the student name from the course and the student name from the student. So union operation I am applying. So what is the output? Just tell me right now.
Sir, a new column will arrive that will be age, and it will have like it will be arranged as such the course IDs. No, the student ID is there. As per the student ID, then age will be there.
See, you people are not observing the other common attribute we must have performing the binary operation. So student ID is a common attribute. You must be take care of these points. In these two tables, we must have we are having a this one. If we don't have a common attribute, so how we can perform the binary operation properly? So we must have the common column. So if I'm having this one, if I'm applying the union operation, this 901, 901 we have. Okay. 901, we have 901, so no issue. 901 again we have, so it will be mapped to this one. 911, yes, of course, 911 we have. 921, 921. And 931, 931, it is mapped. Okay. So what it will display if I'm writing the course union student. So all the attributes at the left hand side will come first. So student name, that is Aditya, Steve, and Paul. So what it will keep? It will display. It will display the that is a Aditya. Then it will represent the Aditya. Then it will display the Steve, Paul, and Lucy. Steve, Paul, Lucy. And if I'm just observing over here, Aditya, Steve, Paul, and Lucy are also already in the our student name list. So Carl and Rick are left. Okay, Carl and Rick are the left. It is true right now. So in the next part, remaining student name, that is a Carl and Rick will come. Aditya is already duplicate, so it will be removed. While using the union operation, duplicate record or duplicate rows will not be applicable. So as you can see over here, you can see over after sometimes you will see there are no duplicate names present in the output, even though we had new common names in the both few common names in the both the tables, also in the course table, and we had the duplicate name itself. So Adit will not be come many times because it will represent duplicate. So Adit, Steve, Paul, Lucy, Carl, it will be displayed over here. So just let me show the my proof. Let me remove this all this one. Student name will display Aditya, Carl, Paul, Lucy, Rick, and Steve. So you can see here no duplicate records is coming, no duplicate name is coming over. So union operation, what we can say is saying to us union operation does not include duplicate value, as we know in the mathematical we know. Now clear? This is clear to all right now? Union operation is clear?
Yes, sir.
In order to understand this union operation, I have explained with the example. It is clear?
Yes.
Okay, now, yeah, okay, good. So now look at this example. Tell me, if I'm using the intersection operator rather than the union operation, so what would be the output? Just see this example and tell me, rather than the union operation, if I'm applying the intersection operation, then what would be the output? Just can anyone tell me right now?
So
So
Aditya, Steve, and Paul, and Lucy.
Aditya, Steve, Paul,
And Lucy.
and Lucy. Why? Can you explain your answer?
Because like intersection takes the values that are common.
Common. That's a great point. You are telling me right now you are on the right track. Yes, absolutely on the right. So you can see the Aditya, Stephen, Paul, Lucy are the common attribute, common values which are also live in the student. But Carl is not possible. Okay, so that is the point we have to understand. Rick is also not possible because Rick and Carl are not the part of the course relation. So definitely we will have this output. So we have this one. Yeah, this is the output intersection operator. So intersection operator symbol will be the R intersection R1 R intersection R2. So just I'm using this one. See, car and it does not exist and does not supported by the course. So we have this one. Now clear right now?
Yes, sir.
So fundamental operations, what we have seen, select operation, project operation, rename operation, and union and intersection operator are the addition operator we have seen. Okay, now let us move to the some other operations. Set difference. Set difference is denoted by the negative symbol, and we have to understand this symbol is very simple. If I'm using the set difference, so it's saying to us, if I'm writing, see, definitely we have to understand this point. The relation we should have in the R1 intersection, R1 set difference, R2 I'm writing. So the relation, the information that lies between the R1 but does not lie into the R2. This is the point. Okay, so it is saying to us, I can speak over here in simple way. What is saying to us? Select all the tuples and select all the tuples or rows that are present in the relation R1. If I'm speaking about the R1 intersection, R1 set difference R2. So I'll select all the tuples rows that are present in the relation R1 but does not or but not present to the R2. So this can be known as the set difference, and it's denoted by the R1, this one. Now clear? This theoretical point is clear?
Yes, sir.
So if I'm writing the course interset difference student, then what would be the output? So see this result, see this table and tell me. See this table and tell me what would be the output.
Carl and
This is
Rick.
Carl and Rick. Why?
So because Carl and Rick, they're present in student, but they are not present in course. So R2 minus R1 will be Carl and Rick.
So let me inform you once again over here. This is a great point I'm getting over here. So see, this is the point we need to discuss over here. So you can say R1 minus R2 means the data that belong to the R1 but not into the R2. But reverse part I'm writing R2 minus R1, so it means data that belong to the R2 but not in the R1. So from which relation you are taking at the left side or from which relation you are moving from the right side, it's your choice. But if I'm changing something, I'm changing the order. Union intersection, no issue. But at the time of the set difference, it just gives the different result. So from which perception you want to read, it's your choice. So these are the two relations. So if I'm writing the R1 minus R2, so R1 I'm taking as a student and R2 I'm taking as a course. So car and Rick will be displayed because which are not available in the course relation. But if I'm writing the R2 minus R1, this is the great answer I'm getting. But I'm writing here, R2 minus R1. So in this case, what happened? What would be the output? What would be the output? Just tell me right now. In the R2, but which is not in the R1. So Aditya, Steve, Paul and Lucy will come. Just tell me right now, it will come. Just tell me what would be the output.
So it will show a blank.
Yes, why it will say blank? Tell me right now.
So because all the values present in course, Aditya, Steve, Paul, and Lucy, they are also available in student.
Okay, that's the great answer I'm getting. So it will not display or select any data. That is a big point we have to keep in mind, because what happened is student will be in hurry when the exam time, so they will write as Aditya, Steve, Paul, and Lucy. That is the example, that is the answer of the union we have seen. So you can't differentiate, you must be differentiate union and the set difference properly. So that is the point. So R2 minus R1 if I'm doing, it means course set difference between the R1. So we will get the blank data because we are not having the common thing which are not live over here. So that is the point. But in the case of the R1, R2, the car and Rick are the value that does not belong to our end relation. So we will use these values. That is the point. But R2, R1 if I'm doing, so all the data where they belong to the R2, that is also belong to the R1. So definitely nothing is possible. This is a little bit difference we have to keep in mind. Now, clear? This is the basic difference. Difference is clear to you all right now. Basic difference is clear. Yeah, definitely we should have. So this is set difference. I'm taking the student and course. So R2 minus R1 I'm doing. So I will keep the Carl and Rick. Okay. And if I'm doing the R2 minus R1, so course minus the student if I'm doing, so I will get the null. It means all the values of the name are exist inside the student. Now the basic concept should be clear. Now it is clear to all right now.
Yes, sir.
Yes, sir.
Okay, good. So this is the various operation we are looking in the decision engine. So I've explained with others, so I just want right now. Now next we have the Cartesian product. Cartesian product is more important because it will keep the duplicate record. So I'm reading some points over here, so listen carefully. Cartesian product is denoted by the cross symbol. And let's say we have two relations R1 and R2. So the Cartesian product of these two relations will be the R1 cross R2 and would combine each tuples of the first relation R1 with each tuple of the second relation, that is R2. So I know it sounds confusing, but once we take an example of this, you will be able to understand this concept in a simple way. So I'm writing syntax R1 cross R2. It means R1 will contain some data and R2 contain some data. So, but before that, moving to all, just let me inform you. Suppose student is relation, we have the 50 record, and faculty record we have 100 records. So if I'm using the student into faculty, so I will keep the 5,000 data. So what I'm doing, I'm putting the Cartesian product. Now, this is a fundamental point you have to understand. Let us understand this thing with the help of the word example. And let me explain this example with a simple way. Then I can explain. This is the point. I'm just removing the unnecessary point over here. What you are expecting, that is the point. See, we have a two relation. One is R and S. Okay. First, R is a relation which contain the how many tuples? 3. In the S relation, we contain the how many tuples? 3. So if I'm doing the R into S or R cross S, so it will represent the 3 into 3. So total 9 record will be there. And now let me explain why. I'm not talking about the column, I'm talking about the row. So this will be R into S. So this will be combined with this record first. And this will be combined this record first. And this will be combined this record first. Just tell me right now. It is clear? Just tell me. Okay. Yeah. Next, what happened? Next, this record will be chosen. So it will combine to this one first. It will combine to first, and it will combine to first. So now, how many we have? 6. Next, Now next time to select this point. So it will combine to this x double x and then double y and double z. So by seeing the different colors, you can easily check the total. We have a 3 into 3, total 9 we have. This is a Cartesian product. If I'm doing the reverse part, so it is also total number of the element we can get the same, but the sequence of the order may change. This is a well example. Now it is clear to all right now. The Cartesian product result is clear to all right now. The Cartesian product between all the things.
Yes, sir.
First AA, then BB, then CC. If I'm using the S into R, then what happened? What happened? X will come first. Okay, X will come first, and then Y will come first, and then Z will come first. But only order will change, but total number of the element will be equal. So what we will do here, we are observing duplicacy we are having in the use volume. That is only point. So the number of the rows in the output will be always be the cross product of the number of the rows in each table. And in our example, table 1 has the 3 rows and table 2 has the 3 rows. So the output has the 9 in 3 into 3, that is the 9 rows. Now clear, this Cartesian product is clear right now. Tell me any doubt over here? Yes, tell me right now any doubt? So in the examination, if I share some question based on the relational algebra, then you will be able to solve. Is it true?
Yes, sir.
Yes, sir.
Oh, okay, good. So this is